Hi, this is Mr. Gillum, and today we're going to learn about some transformations, and we need to identify what's happening, and then we need to actually call it by name. So transformations, there's a lot of different ones, and we're going to talk about different ones for how graphs move around. So here we go. Let's take a look. Now, when I say transformation, I want you to think of like a transformer, all right? Now, a lot of different things can happen on this transformer when he changes from Bumblebee to this little car here. All right, a lot of different things change. Some of the parts stretch, some of them compress, some of them rotate, some of them reflect, some of them do all this other stuff, okay? Those are all different types of transformations. So the reason I'm telling you this is because sometimes people get transformations and translations mixed up. Transformations like a transformer, all kinds of stuff's going on. A translation, though, is just a slide. Okay, and we see translations a lot in geometry, but we also see them with graphs. Okay, so what's happening here on this first illustration here, this is more of a geometrical example. What's happening is it's moving 2 units to the right and 4 units up. And A moves 2 and 4 up. And C moves right 2 and up 4. This is a slide, it's just sliding. Okay, so what we would say is from the original to the new one, we would say that it translates right 4 units and, right 2 units and up 4 units. Okay, it's a translation, it's just a shift, it's just moving. All right, on this next one here, if we're starting right here, this little graph, that little fella, and we're moving it 1, 2 spots to the left and down 1, we would say that it translates, because it's just a slide, left 2 units and down 1 unit. Okay, it's just moving over and then down. And then finally, we have one like this little fella right here, where if we're starting right here on this part, the whole graph just moves 3 to the right. So we would just say translates right 3 units. Okay, so translation is just a shift, okay, but we need to actually use our words. So the reason I'm having you write out the word translate is because it's easy to confuse with transform. Okay, translate moves it, just it's a shift, it's a slide. Right? Reflection, like a mirroring, that's what it is. It's like a mirroring. Now, in geometry, it can be, well, in anything, it can be mirrored over any kind of axis, any kind of line, but mainly on a graph, it will reflect over the y-axis or the x-axis. All right, so this little fella right here, this geometrical, that would reflect, it's hard to see that color, reflect over the y-axis. So you can see this point was one unit away, and now it's still 1 unit away. This was 1, 2, 3 units away, and on the other side it's 3 units away. This guy was 2 units away. All right, or 1 and 1. So it's just a reflection, and this is called the line of symmetry, or the line of reflection. Okay, in this case, it just happens to be the y-axis. Okay, now there's a couple different types of symmetry going on right here. Okay, there's this reflection of this line is reflecting over the y-axis, but if I look at this graph as a whole and I compare it to the new graph over here, what's happening is I had this V on the top half, and now I have this V on the bottom part of my graph. And what's happening is it's reflecting over this sideways axis. So we're going to say this reflects over the x-axis. All right, and for most of our functions, they're going to reflect over the x-axis more often than not, because usually we set up our equations as y equals. And we're going to talk about the relationship of the negative number in front of the function later, but you have done a little discovering with Desmos that if you put a negative in front of that function, it's going to flip it over that x-axis. Okay, so we're just going to put words with it now. Okay, and finally, if I start with this graph that looks like this guy right here, and I flip it over like such, and put that negative in front, I know that, once again, it is reflecting, or reflects over the x-axis. All right, So now the next transformation that I'm talking about here is a rotation. And generally our functions, which we're talking about in algebra, don't do rotations. They do reflections and translations and stretchings and dilations and compressings and things like that, but they don't generally rotate. So this is just a geometrical example, and I threw it in here because a rotation is a type of transformation. However, generally, there's not a lot of rotations as we add numbers into our equations. Okay, but I think you know what a rotation was. Type of transformation. Finally, we have a dilation. And a dilation can be a stretch or a compress. Now, when we stretch, we're stretching vertically. Okay, we're getting skinnier. Or we're compressing, we're squishing it down and getting fatter. Okay, so if I'm going from purple to blue here, I'm starting with a small triangle and I'm getting bigger. Okay, I'm going to call that a stretch. I'm stretching it out. Okay, however, its dimensions, there's a relationship there. If I look at the purple compared to the blue ones here, I see that the x-coordinate went from -2 to -4, 1 to 2, and 0 to 0. And -2 to -4, -1 to -2, and 2 to 4. So basically, everything is being multiplied by 2. So I'm going to say this is stretched by a factor of 2. Okay, and the same kind of thing works with our functions over here. Okay, this is another one of those instances where this point 1, 3 changes into 2, 6. And so 2, 2 will be 4, 4, and so on. So I know once again, since I'm getting from small to big, that I'm stretching by a factor. I just abbreviated a factor as AF. It's not appropriate. By a factor of 2. All right. And in the equation, it's obvious what the factor is because that's usually the number you add into the equation. So if I'm starting with this little guy right here, and he's getting skinnier on the inside, I know that he is stretching by a factor. This is the original, and this is the next equation, by a factor of 2. So once again, 3 examples of the same exact transformation. Stretching by a factor of 2. Instead of writing it all out again, I'm going to say that is the same thing as that guy right there. Okay, instead of a shape, it's a function, and the same kind of things happen. Finally, this dashed line right here, this is going to be my original. I'm going to call it the parent function. That guy's the original. And 2 things are happening. One, we have this stretch in here, once again, and this time the equation is hard to tell, but they put a 4 in there on me. And the second part is this little guy right here, where I got fatter. That's a compress, and this time looks like the number that they threw in the equation was 1/4. So this is called a compression. So the yellow one is stretched. Can't see that at all. Stretched by a factor of, in this case, it says 4. And this other one here is compressed. It's getting shorter and fatter by a factor of 1/4. All right. So we have all these different types of transformations. We have a stretch, compress, those are types of dilations. We have rotation, reflection, and translation. They're all different types of transformations. And that's it for today.